Okay, guys, we are to the final lesson in Unit 1. And this is going to be a little different, a little challenging, but hang in there, and I'll do my best to explain it, try to make it simple for you. First of all, let's go back to something you're really comfortable with. Just plot this point, which means go left 2, up 3. All right. So what the heck is this? Well, I'm going to introduce something to you. I want you to take a look over here. You see these z's in the equation? That's what we have here. We've got an x, a y, and a z. So what we did in 1/6 day 1 is going to be very, very instrumental in 1/6 day 2. So 1/6 day 1, we dealt with two variables, x and y, x and y, x and y. And as you can see, now we got x, y, and z. So just to help you understand what the heck it is, what even is z, so you guys are used to the x-axis, you're used to the y-axis. But if I plotted this point, x, go left 2, y, go up 3, and then go out the z-axis. What in the world is the z-axis? Handy dandy eraser right here. Comes right out of the origin, and it's coming right out of the board, but it's also going behind the board. So we're going to consider this the positive side. Behind the board would be negative. That means we'd have to come out the eraser 6 units. So 1, 2, 3, 4, 5, 6. So if I take this eraser away, that's right where that point is. It's in space. So this is actually 3-dimensional graphing. We have another variable to worry about, and that's z. So what have we been doing? We've been solving systems of equations. But the ones we just got done with only have x and y. Now again, we have z. This is the easiest possible example you'd ever run across, because if you just use your noggin, I'm trying to find x, y, and z. And if you rub a couple brain cells together, you're like, wait a minute, there's nothing I can do with this. There's nothing I can do with this all by itself. Well, look at this. If I just divide both sides by 2, I'd get, hey, z is 2. Well, I found my first piece, 2, a positive 2. All right. Well, how am I going to find y and x? Am I going to find them at the same time or one at a time? You're going to find them one at a time, because we're just going to climb the ladder with this piece of information. We're going to put it right here. So y minus 3 times z equals 6, which is just y minus 6 equals 6. Don't think for a second. These cancel each other. A lot of students make that mistake. Add 6, y equals 12. So here we go. We're going right down the list. What's the last thing I need to find? I got to find x. Where's that? Right here. It's the only equation that has the x in it. So we're going to take this guy and understand that y equals 12, we're going to put it in there. Z equals 2, we're going to put it in there, and then the only variable remaining would be x. So x, that x, plus y, plus 2 times our z equals 1. So this is just x plus 12 plus 4 is 14, right? Yeah. Equals 1. Hold on a second. I knew something didn't feel quite right. Simple math error. 12 plus 4 is not 14. 12 plus 4, what is it, you guys? 16. All right. X equals, if I subtract 16, I get negative 15. So that would be my solution right here. My x, my y, my z. Okay. I got to pause it, put some more stuff on the board. I'll be right back. Okay, something I wanted to make sure is clear with you guys. Here's an equation of a line. You guys are very familiar with this. And if I plotted this, there's my y-intercept, 1, 2, 3. And then my slope is up 2, right 1. So my line would be right there. Why am I showing this to you? Something you need to kind of grasp is this. If I just multiply this all by 2, I would get 2y equals 4x plus 6. Now the question is this a different line? And the answer is no, because all this is, it's this equation doubled. Now, what does that mean? Well, let's just take a look here and plot some points just to prove my point here. I know this point right here is 0, 3. So I'm going to put a 0 in for x. So if I put a 0 in for x, that would cancel this term. I'd get 2y equals 0 plus 6. Divide by 2, divide by 2, I'd get y is 3. That's a 3. And so it's the same point. Well, what's this point right here? Well, it's over 1, and then it's up 5. So I know it's 1, 5. Let's act like we didn't know that. And just say, hey, let's put an x equals 1 in for right here. So I'd get 2y equals 4 times 1 plus 6. That's 2y equals 4 plus 6, which is 10. Divided by 2, I get y is 5. So, as you can see, 1, 5, they share the same 2 points. Guess what? That means when I multiply a line or an equation by something, it doesn't change the graph. It just changes what it looks like. So, keep that in mind as I move forward onto this problem. I'm going to erase this a second. Okay, so in addition to that, what I just showed you right here, what we know is from yesterday, 1-6 day 1, is we are completely skilled. We can use substitution and elimination when we're dealing with 2 variables, x and y. Now, what our goal is, because we're used to x's and y's, what we're going to try to do is we're going to take these 3 equations that have x, y, and z's, and our goal is to create 2 equations. But the difference is we only want 2 variables. Now, how are you going to do that? Well, I'm going to have you guys look at these 2 right here, okay? So if I was to just look at it, and remember, it's okay to add equations. And why am I talking about that? Because this negative z and this positive z are just begging you to look at me, we're opposites. So if we added these 2 together right here, and I looked at this and I said, okay, 2x minus x is x, or 2x plus negative x is x. Y plus 2y is 3y. And then I get negative z plus z is 0, gone, equals negative 10 plus 3 is negative 7. Some of you are going to say, well, what if I didn't notice that? Well, that's what this is all about, is noticing what some strategies are. And every problem's a little different. That's why some students get a little stressed out. There's no step 1, step 2, step 3. Every problem's going to be a little different. But I want you to notice, I have one equation with 2 variables now. Now I've got to get creative and do something else with, see, I just manipulated equation number 1 and equation number 2 by adding them. And we got, aha, we're heading somewhere. Now we got to get creative with a combination of 2 others. And what I'm going to pick is these 2. Now I'm going to use a strategy. Remember, I eliminated z by adding equations 1 and 2 together. So I want to eliminate z again using a different strategy. But this is a strategy you've done before. It's just you got more stuff. So I'm going to ask myself, what plus 3z would give me 0? And the answer is negative 3z. So what do I need to multiply this top equation by to create this? I'm going to multiply this all by 3, because 3 times negative z gives me what I need. I don't care about this, this, or this. I just want opposites here. So this times this is 6x. This times this is 3y. That times that gives me what I needed. And 3 times negative 10 is negative 30. Now remember, why do we do that? Because we're going to add these together. and eliminate my z's. So 6x and x is 7x, 2y and 3y is 5y. These are gone, what I wanted to do, equals negative 30 plus 13 is negative 17. Now if I take this one right over here, I am ready to rock and roll. So I've taken this crazy thing with 3 variables and I've manipulated it so I only have 2. Don't be intimidated, this takes a little practice. And now I'm just going to go back to the old drawing board and say, okay, I'm going to multiply this. I'm going to concentrate on my x's by negative 7. So distribute. Negative 7x minus 21y equals 49. I'm going to add these two together because I have opposites in my x's, and those are going to cancel. So I get negative 16y equals 49 minus 17, fortunately, gives us 32. Look how that works out. Negative 16, so y equals negative 2. Don't forget, we're trying to find x, y, and z. Well, we just found our y is negative 2. Where are we going to find our x? I'm going to take that negative 2. I could put it here, or I could put it here. I'm going to choose the top one because it looks a little easier. X plus 3 times negative 2 equals negative 7. Now I know that's negative 6, so I'm going to add 6 and add 6. I know this is negative 1. So now my x is negative 1. Look, I know my x, I know my y, I just need to find my z. Where am I going to find that? Well, I can plug it into any one of the 3 originals. See, and I erase the second one. I'm going to use the top one. So I know it's 2x plus y minus z equals negative 10. So I'm going to put the negative 1 in here. So 2 times negative 1 plus whatever my y is minus z. It's why important to, in this class, make a little slash in your z's so they don't look like 2's. Equals negative 10. That's negative 2, and negative 2 is negative 4 minus z equals negative 10. Add 4. So I get negative z equals negative 6. That means positive z equals positive 6. They've got to multiply that by negative 1. And there's my solution. It's the first time you've seen one like this. Don't panic. You're going to see a couple more on those example problems, and just look for that strategy, okay? You're going to have to be creative here. Good luck.